Now this is for molality. And I'm kind of starting with this information right here, but I kind of also, it could be helpful to use this information right here, because this is going to get me to grams of solution. And if I can get to grams of solution, I can use the density to get to moles of solution. Let's see here. Okay. So I've got my molality, my 0.344 moles of KBr. So I got that. And then for molality, I'm going to take that 0.344 moles of KBr and I'm going to turn them into grams. So that's grams of KBr. And then I'm going to say, okay, if I can just add it to what I already have with this, which is 1,000 grams, what that's going to give me is my grams of solution. Once I get that, if I can then, again, like I said, that's grams plus grams is grams of solution. Once I get that, I can say grams of solution and liters of solution. And that number was that 511 number. So again, like I said, this together will be grams of solution because this is grams of solvent and this is grams of solute. I'm going to put all of that in my calculator like that. 0.344 divided by parentheses. 0.344 times 102.89 plus 1,000. And then that number divided by 511. I need to make sure that that's staying in my denominator. I'm short a parentheses over here. That will make everything in my denominator. Make sure that it didn't delete anything. Yeah. So that number is going to be 0.0048 molarity. And it's not that far off. It's a little bit off from that originally number, that 0.344, but it's only like, you know, a little bit off. It's not crazy off from that number. I do like to see the numbers generally being close together. The more on the extreme of the molality, like the small percentages or the larger percentages, like 80s, 90s, those don't always work out to be as close together for molarity and molality.